Will a precipitate form? This is a common question that we ask, not just in the lab, but in real life. So will a precipitate form really is looking at KSP and looking at it against Ki. So remember that Ki is that instantaneous K value, and we're looking to see whether or not it exceeds or hasn't reached my KSP value. KSP, again, is just another KEQ expression, really looking at the limit of solubility. So reminder that whenever I'm talking about my KSP expression, it's always of my ionic solid dissociating into my aqueous ions. And just like KEQ, if my Ki expression is greater than that, then my reaction will shift left. And in this case, shifting left means that I'm going to cause more solid to start to appear. So you guys saw this in your double replacement your 8 solutions lab or your characteristic chemical reactions lab. When you had ion concentrations that were mixed together that were too much for the KSP value of your reaction, then you saw a precipitate. And we made sure that your ion concentrations were high enough so that you would actually see this. So here's an example. If the KSP for silver chloride is 9 times 10 to the negative 9th, will a precipitate form if 350 milliliters of a 2 times 10 to the negative 4th molar solution of silver nitrate is mixed with 250 milliliters of a 4 times 10 to the negative 5th molar solution of sodium chloride. Boo. Basically what I'm doing is I'm combining silver nitrate with sodium chloride and seeing if my ion concentrations are going to exceed that. Now, because you're mixing solutions, the concentration of each of the individual solutions is going to go down. It's kind of like having juice and adding water to it. Because I'm adding something to it, my orange juice will be diluted. If I add orange juice and apple juice, my orange juice is still being diluted. My apple juice is also being diluted. I'm just getting a strange mixture of 2 diluted juices, orange and apple juice. Some people like that, some people don't. So the same thing is happening here. Both my silver nitrate solution and my sodium chloride solution are being diluted, so these molarities will go down. So the first step is you write your net ionic equation. So the solid is what is forming, right? So solid silver chloride. So it's really the silver ion and the chloride ion that are forming to form silver chloride. Then I have to rewrite this as a dissociation reaction because I'm going to be using my KSP expression. So I rewrite this backwards as a dissociation reaction of silver chloride dissociating to form silver ion and chloride ion. I write my KSP expression, and then I calculate the new Ki with the new concentrations, right? So silver ion, the silver ion here, came from my new silver nitrate ion concentration. So my old one was 2 times 10 to the negative 4th. I had 350 milliliters of it. But now that 350 milliliters of my 2 times 10 to the negative 4th molar solution is now diluted, and now my total solution is greater than that. It's 350 plus 250 milliliters. So my chloride ion concentration, same thing. My chloride ion concentration came from my sodium chloride ion concentration. That came in as 4 times 10 to the negative 5th molar, and I had 250 milliliters of that. But now I'm diluting it, and my total solution is now greater. So these two values multiplied together give me the moles that I put in. That stays constant, but my total volume will increase, which is why my molarity will now, my concentration will now decrease. Same thing here. These two values multiplied together will give me the number of moles that I put into solution. Now I have to put it over the new total volume, which will give me my new concentration. So I'm still doing moles per liter. You don't have to convert to liters here because I'm crossing milliliters out with milliliters. So I plug that into my KSP expression, my Ki values. So again, that's my silver ion concentration and my chloride ion concentration. And my KSP expression was just simply multiplying these two together. And I get, so you'll notice that my silver ion concentration went from 2 times 10 to the negative 4th molar down to 1.2 times 10 to the negative 4th. Not quite 2, not quite in half, because I haven't really diluted it by half. I've only added 250 milliliters, not another 350 milliliters. This, however, went down more than half because I went from 250 milliliters and I added 350 milliliters. So it makes sense that this concentration right here, 4 times 10 to the negative fifth, went down to 1.75 times 10 to the negative fifth. So these are my new silver and chloride ion concentrations once I've mixed my two solutions together. I multiply them together and I get 2.1 times 10 to the negative ninth. That's lower than the given KSP, which was 9 times 10 to the negative ninth. I'm getting very close to it, but basically a precipitate will not form. So what does that mean? That means that if you put in this molarity, these concentrations at these volumes of silver nitrate and sodium chloride, even though a precipitate could form, if we didn't make the concentrations of your solutions high enough, you wouldn't see a precipitate form and you'd think that no reaction occurred. So again, when we're doing your characteristic chemical reactions or your 8 solutions lab, it's always important that we have a concentration that's high enough so that you will actually get an expected result. Here's another thing that we can take advantage of. We can look at what happens when we add a common ion. We often do this in medical situations and even environmental situations, and I'll talk about which ones they are. So let's say I'm looking at lead-2 chloride that has a KSP of 1.6 times 10 to the negative fifth. So first, let's act as if I have lead-2 chloride that has got dumped into some situation, and I want to know what those ion concentrations are at equilibrium. So if then 200 milliliters of a 1 times 10 to the negative second molar solution of sodium chloride is added to 600 milliliters of a lead-2 chloride solution at equilibrium, what's going to happen? So the first thing I'm going to do is I'm going to calculate my ion concentrations as if all I have is my lead-2 chloride in there. So it's going to reach equilibrium. I put my KSP value in, again my lead ion concentration times my chloride ion concentration squared, coefficients, and that's my given KSP value. Plug it in. This is a solid, so I'm not even going to entertain it in the expression. So when it dissociates, I create X moles of Pb plus 2 ions and 2 times that, my coefficients, of my chloride ion concentration. Plug that into my KSP expression, I get 4x cubed, because remember the square applies to the number and the variable, is equal to 1.6 times 10 to the negative fifth. X is equal to my lead ion concentration, 2x is equal to my chloride ion concentration. So at equilibrium, I expect to have 1.58 times 10 to the negative second moles per liter of lead-2 ions, and twice that, or 3.17 times 10 to the negative second moles per liter of chloride ions. I'm at equilibrium. So if I then add sodium chloride to the solution, right, I'm at equilibrium. If I add more chloride ion to this goes up. In order to keep this KSP value constant, which it is, my lead ion concentration will have to go down. The only way my lead ion concentration can go down is if it basically shifts left and I create a precipitate. So what we're seeing is that if I add the chloride ion concentration for my lead-2 chloride, which was 3.17 times 10 to the negative second molar, and I had 600 milliliters of that, and then I have to multiply it by 2, and I have the chloride ion concentration from just my NaCl, right here, and then I put it all over the total solution, that will equal my chloride ion concentration, my new chloride ion concentration, which is 2.98 times 10 to the negative first molar. So I plug that in right here, and I'm now asking, what does my lead ion concentration have to be in order to keep this KSP expression the same, now that I have spiked my chloride ion concentration by adding sodium chloride? Sodium does nothing. All I'm doing is adding the chloride ion. That's the common ion. And what happens is my lead ion concentration has to go down. It goes down from 1.58 times 10 to the negative second down to 1.8 times 10 to the negative fourth molar. An astonishingly lower number. It's it's 100 times lower than it was here. And so what's happening is that I'm precipitating out, I'm causing it to shift left and create lead-2 chloride. This is actually an important thing that we do in medicine. If you have lead poisoning, right? The lead poisoning is really the lead 2 plus ion that is in your blood. That's causing the problem. Solid lead 2 chloride, solid lead whatever, does not cause a reaction. It's only when it's in its ion form that it then can take the place of iron in its ion form in your hemoglobin and just wreak havoc in your red blood cells. So for kids who have lead poisoning, or anybody who has lead poisoning, one of the things that we do is we add a common ion, oftentimes in the form of just a salt solution, sodium chloride solution, that will then cause the chloride ion concentration to increase, and what I do is I then precipitate out the lead 2 chloride and flush it out of the system, which is just a fancy way of saying I give the person lots of diarrhea and I rehydrate them while I'm doing this, just so you're just pooping out all of the lead 2 chloride. This is the way that we basically get over acute lead poisoning. This can be true of any other ions. If they have a KSP value that we can take advantage of, we can try and basically precipitate it out. And if it's precipitated, it can't form nearly the problems that it does if it's not precipitated. So again, you can use this Ki stuff in order to figure out, will a precipitate form if I mix these two solutions together? Or what happens if I add a common ion to that? The thing is the same. I write my KSP expression, I plug in the concentrations after I've diluted them, and then evaluate the Ki next to my KSP and figure out whether my reaction is going to shift left or shift right. If I shift left, then I'm creating a precipitate, and the answer is yes, a precipitate will form. Always remember to, if you're just asked whether a precipitate will form or not, to always finish things by inspection first, meaning just looking at the 10 to the whatever power and plugging that in, because oftentimes that will save you a lot of time and needless worry.